Assalamu alaikum. My name is Aksar Shafiq, roll number 21TE08. Today we are diving into the fascinating world of digital signal processing right there. In this lab, I have got a bunch of tasks lined up that showcase the magic of digital signal processing and how it plays a crucial role in various applications. Now I am going to explain the task number 1 of this lab, in which we have to tell the actual meaning of the term digital in the context of digital signal processing. So now we will talk about digital signal processing and decoding the term digital. In digital signal processing, digital means representing signals using specific values, not smooth curves like in the analog world. Think of it as taking snapshots of the signal at different moments and making it easier to work with. We have discrete representation, quantization, and representation of information as an features of the digital signal processing. First, this discrete representation tells us the smooth wave into the sequence of numbers. It's like taking pictures of a moving object, capturing it at different times. Discrete representation means keeping the things finite, and we can also say that discrete representation is the finite number of objects in the real world. Quantization are the numbers needed values, so we use quantization. It's like picking colors for a picture, rounding the number to something manageable. Representation of information. All the important information about the signals gets encoded in these numbers. It's like creating a digital version that computers can understand and process easily. So in DSP, digital signal processing, digital means turning signals into specific numbers, making them computer friendly. Now let's move to our task number 2, that is that how we can uh, choose between linear search and binary search in DSP applications. Illustrate the relationship between digital data and sorting. हमें यहाँ पे ये बताना है कि जो हम डिजिटल डाटा को सेलेक्ट करते हैं ड्यू टू इट्स फीचर जिसमें एक सॉर्टिंग भी आता है, तो उसमें हम लीनियर सर्चिंग और बाइनरी सर्चिंग डीएसपी में हम कैसे कर सकते हैं. So now we will discuss how we will pick between linear search and binary search in digital signal processing that shows a lot about digital data and sorting. So the first feature is linear search. Linear searching is like flipping through a book page by page until you find what you are looking for it. In the digital world, it's like scanning through data step by step, one by one. But here is the deal, it's not super fast. For big data sets, it is a bit like looking for a needle in your high stack. Not linear search is not ideal for picking it. Binary search. Binary search is a smarter one. It relies on the fact that your data is sorted like having a nicely organized bookshelf. It keeps diving the data in half until it finds what it's after. But and it's it's one of the disadvantages that data needs to be sorted for this to work well. That means some extra work to keep things in order. The third one is efficiency talk. Okay, here is the deal with efficiency. Linear search can be a bit slow, especially for big tasks. It's like looking for your favorite snacks in your messy um, pantry that will take time. But binary search is like having a well organized pantry, even though you might need to tidy up now and then sorting, finding things in lightning fast. So it's a trade off between keeping things sorted and searching like a speed demon. Implications. How or where we can apply DSP. Speaking of trade-offs in DSP, we will deal real life stuff. Speed matters. If your data changes a lot, sorting it all the time might slow down things. So there you have to the relationship between digital data sorting and search efficiency. It's all about finding the sweet spot between organization. Moving towards task number 3. Task number 3 is about that in the domain of digital data, what strategies and techniques can be employed to enhance data transmission efficiency. Here are some of the techniques that we can use to improve the data transmission efficiency, in which eh, compression, error detection and correction, caching, parallelizations, protocol optimizations are some of them. Compression. Compression reduces the size of data through compression algorithms, through which we can minimize the amount of data transmitted. Error detection and correction. Error detection and correction are used for reducing the errors in the data. Implement error checking mechanism to detect and correct error during transmission. That will ensure efficiency of the data transmission. Caching. Caching is store frequently accessed data locally to reduce the need for repeated transmission. Now moving towards parallelization. In parallelization, transmit data concurrently through multiple channels or paths to expedite the overall transmission process. Protocol optimization. Protocol optimization uses efficient communication protocols that tailor to the specific requirement and characterize of the data transmit and characteristics of the data being transmitted. Task number 4. Task number 4 will give us, or it will generate and plot a sinusoidal signal. Let's break down the code and explain each part of it. The first line is used as a comment line that will provide a brief description about the task, that is plotting sinusoids in MATLAB. The second line creates a time vector t using the colon operator. The vector starts from 0, increments by 0.01 and goes up to 1. This means that t will have values from 0 to 1 with a step size of 0.01. The time vector is often used to represent the time axis when plotting signals. The next line, where f is equals to 1, this line sets the frequency f of the sinusoidal signal to 1 Hz. In next line, signal is equals to sine f2 pi t. This line generates the sinusoidal signal using the sine function in MATLAB. The formula sine f2 pi by t represents a sine wave with the frequency f and the time vector t, and the 2 pi factor is used to convert the frequency from hertz to radians per second. Plot t, signal. This line plots the sinusoidal signal. The plot function is used to create two t-line plots. The first argument t is the axis x-axis values, and the second argument signal is the y-axis values. The resulting plot will show a sinusoidal wave over the specified time range. When you will run this code, this will give us a plot that will display a sinusoidal waveform with a graph of 1 Hz over the time range from 0 to 1. The step size of 0.01 in the time vector provides a smooth representation of the sinusoidal signal that you can also see in the provided output. Task number 5. The provided MATLAB code in task number 5 is built upon the previous code for plotting a sinusoidal signal, but it adds some of the additional features such as title, axis labels, and customized axis bounds. Let's break down the code and explain each part. The first line is used as a comment that is describing that the code is about adding titles, labels, and axis bound to the signal graph. The next line t introduces a time vector t. F is equals to 1 is introducing the frequency of the sinusoidal signal of 1 Hz. The next line generates the sinusoidal signal using the sine function, whose values is sine f2 pi by t. The next line will plot the sinusoidal signal as before, and the code will be plot t comma signal in brackets. Title plot of sine wave 1 Hz. It is a line that adds a title to the plot specifying that it is a plot of sine wave with a frequency of 1 Hz. Then the next one, Y label. Y label is here used to add the amplitude, representation of the amplitude of the signal. This line adds a label to the y-axis indicating that the vertical axis represents the amplitude of the signal. Similarly, X label that is in time seconds. This line adds a label to the x-axis indicating that the horizontal axis represents time in seconds. The ninth line, axis 0.1, 1.5 minus 1.5 or 1.5. This line sets a custom axis bounds for the plot. The specified bounds are x minimum, x maximum, y minimum, y maximum, defining the range for both the x and y axis. In the case the x axis ranges from 0 0.5 minus 0 0.5 to 1.5 and the y axis from ranges to 1.5 minus 1.5 to 1.5. When we will run this code in MATLAB, you will have a plot of sine wave with a frequency of 1 Hz, and the plot will include a title, axis labels, and custom axis bound as specified in code. These additions enhance the clarity and information of the plot for the better interpretation. Task number 6. Task number 6 is about plotting multiple signals in the same figure. Let's break down the code and explain each line of the code. In the first line, we are again introducing a vector t from 0 to 10 with the increment of 0.01. In the second line, we have two frequencies f1 and f2 of the sinusoidal signals, two sinusoidal different signals. In the next line, signal 1, we have given and we have introduced two sinusoidal signal by using sine function for the signal 1 and signal 2. In the next line, the line plots both signal 1 and signal 2 on the same figure. The first pair of the argument t signal 1 represents the x-axis and the y-axis value for the first signal, and the second pair t signal 2 represents the x-axis and y-axis value for the second signal. The sixth line where title is introduced, that is plotting multiple signal in the same figure. In our plot, this line will add a title to the plot. Then the next line adds a label to the y-axis indicating the vertical axis represents amplitude. In the next line adds a label to the x-axis indicating that the horizontal axis represents times in seconds, and the last line represents a custom axis bounds for the plot. The specified bounds are x minimum, x maximum, y minimum, y maximum, defining the range for both the x and y axis. In the case the x axis ranges from 0.1 and the y axis ranging from -1 to 2.1. When you will run this code in MATLAB, it will generate with two sinusoidal signals, each with the different frequencies f1 and f2 displays in the same figure. The plot will include a x-axis and custom axis bound as the specified in the code. Task 7 is about generating a plot of two sinusoidal signals in one figure without connecting the data points. It uses a plot function with the option to display dots for each data point. Additionally, the hold on and the hold off commands are used to overlay multiple points in the same figure. Let's break down the code and explain each part of it. The first line of the code provides a brief description of the task or purpose of the code, and it is used as a command, which is plotting multiple signals in one figure without connecting dots. The next line will generate a vector t that will define from 0 to 10 of 0.01. The next line f is equals to 10 and f2 is equals to 5 to 20. These lines set the frequencies of the two sinusoidal signals. Signal 1 and signal 2 generates the first sinusoidal signal and the second sinusoidal signal. Plot T signal 1 and the dots. This line provides signal 1 with dots at each point. The dot indicate the individual values of the signal without connecting them. Hold on. This command enables hold on mode, allowing subsequent plots to be overlaid on the same figure. Signal 2, this line generates the second sinusoidal signal, and the next line will plot signal 2 with red dots. The red color and dots distinguish this signal from the previous one. Hold off. This command displayed the hold on mode, indicating the subsequent plots should not be overlaid on the current figure. The next line, sound bracket signal to 16,000. This line generates sound based on signal 2 at a sampling rate of 16,000 Hz. The next line is used for title. Y label will represent amplitude, X label will represent the time in seconds, and the last line will set custom X bounds for the plot. When you will run this code in MATLAB, it will generate a plot with two sinusoidal signals, each displayed with dots representing individual data points. The signals are shown in the same figure without connecting the dots, and the plots include a title, axis labels, and a custom axis bound as specified in the code. Additionally, the sound based on signal 2 will be played as well when we will run this code. Task number 8 provide explanation about the concept of functions in MATLAB and provide an example function along with its syntax. Here is a breakdown. Definition of function. We should know what is a function. A function in MATLAB is a group of statements that work together to perform a specific task. Function files. In MATLAB, functions are defined in separate files. The name of the file and the name of the function should be the same. In workspace, functions operates on variable within their workspace known as the local workspace. This local workspace is separate from the workspace accessed at the MATLAB command prompt, which is called the base workspace. Input and output in functions. Functions can be more than one input argument. Functions may also return more than one output argument. Syntax Syntax of a function in a statement. The syntax of a function statement is outlined with this example, which is given function max element minimum element is equals to my function x, also with some other different examples. Calling the function, for calling the function we have another code, big small is equals to my function 4223. This is for calling a function. This statement is for calling the function. As a conclusion, we can say that task 8 explains the fundamental concept of MATLAB function, their structure and how to use them. In task number 9, we have to use mymin MATLAB function that will take a vector as an input and return the minimum value of that vector. So we have written a MATLAB code for that. It will only calculate the minimum value of the input vector but also includes a check for an empty vector which adds the rebootness to your code. This way the function will handle the edge case where the input vector is empty and will display the error message. Let's break down the code. The first line, function min value is equals to my min input vector. The function begins by checking if the input vector is empty using the isEmpty function. Then we will do error handling. If the input vector is empty, an error message is displayed using the error function. This provides a clear and informative message to the user about the issue. In the next line, minimum value calculation. If the input vector is not empty, the function proceeds to calculate the minimum value using the minimum function. So when we will run this code, it will display the minimum value of the vector input vector. This function uses the built-in min function in MATLAB to find the minimum value and the input vector. Also, it includes to check the handle case where the input vector is empty, and here our input vector values have are 38154. So when we will run this code, the built-in min value function will give us the answer 1, which is the minimum value from all the other values. Task number 10 is to use a function mymax that takes a vector as an input and return the maximum value of that vector. So we have to find the maximum value of an vector. In the provided code, first we have an introduced and function whose name is mymax. It and then we will use the if statement whether to check that the input vector is empty or not. Also, we have assigned the input vector values with 38154. If the input vector is empty, we cannot find the maximum value. So then to find the maximum value, we will use the max function, that is a built-in function by the MATLAB, and that is max value is equals to max bracket input vector. So when you will run this code, so you will have answer 8, because from the in the input vector values 3838154, the maximum value it is 8. So this code will provide the maximum value of the input vector. In task 11, we have to make a function myAverage that will take a vector as an input and will return the average value of that vectors. So we will first introduce a function named as average value, myAverage, that will have an input vector. Then we will check if the input vector is empty or not. So in the next line, we have introduced an input vector with some values 38154. Then we will check if input vector is empty, then calculate. It will not calculate the average. If it is not, then it will calculate the average using the mean function. So average value is equals to mean of the input vector. So when we will run this code, we will have the value 4.20, which is the average value of the input vector. In task number 12, we have to make a function mySort that will take a vector as an input and return the sorted vector. Let's make a code for it. Provided MATLAB code will sort our vector input vector values. Let's explain the code. First, the function name is mySort. It takes an one argument input vector which is expected to be a vector. Then we will check input. The function begins by checking if the input vector is empty using isEmpty function. Then we will do an error handling by if the input vector is empty, an error message is displayed using the error function to inform the user that sorting cannot be performed on an empty vector. Then we will do sorting. If the input vector is not empty, the function proceeds to sort the vector using the MATLAB built-in sort function. The sorted result is stored in the variable sorted vector. Function end. The end keyword signifies the end of the function. This function checks if the input vector is empty, and if not, sorts it in ascending order using MATLAB sort function. So when we will run this code, we will have the following output that you can see now. So when we will run this code, we will have our answer 1, 3, 4, 5, 8, which is in ascending order. Task number 13. Make a function myReverse that takes a vector as an input and reverse a reverse vector of given input vector. Here we have to introduce an function myReverse that will reverse a vector, which means the values inside the vector will be reversed. Let's break down the code. First, the function named myReverse is introduced. It takes one input argument input vector which is expected to be a vector. Then input check. The function begins by checking if the input vector is empty or not. Then error handling is done. Then vector reversal. If the input vector is not empty, the function proceeds to reverse the vector using the flipper function. FLIPLR. The function flipper function flips the vector from left to right, effectively reversing the order of its element. The reversed vector is stored in the variable reversed vector. The function is concise and the use of flipper makes this code more simple and efficient for reversing a order. So once you will run this MATLAB code, you will have the input vector in the reverse order, or the values of the input vector have been reversed. Moving towards lab task 14, we have a MATLAB code that will generate and plot two sets of data in a single figure with two subplots. Let's break down the code and explain each part. In the first line, the t will create a time vector t ranging from 0.0 to 0.05 with an increment of 0.01. In the second line, x is equals to rand 50 to 1 in brackets. This line generates a random vector x with 50 elements. The rand function creates values between 0 and 1. In the next line, y is equals to sine 10 to pi t. This line is a sinusoidal vector y with a frequency of 10 Hz over the time vector t. Next line, subplot 1 to 1. This line specifies that subsequent plotting commands will refers to the first subplot in 1 to 1, 1 cross 2 subplot matrix. The next line plots the random data x in the first subplot. Subplot 1, 2, 2. This line will specify that subsequent plotting commands will be referred to the second subplot in a 1 cross 2 subplot matrix. And the last line, plot y, this line will plot the sinusoidal data wave in the second subplot. The use of subplot allows you to dive the figure into a matrix of subplots, and the last digit in the subplot function specifies the index of the subplot to be activated for the subsequent plotting commands. In this case, a 1 cross 2 matrix of subplot is created, and the first subplot is used to plot the random data x, while the second subplot is used to plot the sinusoidal data y. The last task of this lab is task number 15. Make a function win4 that displays four plotting windows in the same figure, that is 2 cross 2 or 1 cross 4 or 4 cross 1. So the provided MATLAB code will give us four different plots. Let's explain the code step by step. First we will do function declaration, and our function name is win4. Our function name is win4. Then create a figure. It will give the command to create a new figure for plotting. Subplots, the function uses subplots to dive the figure into a 2 cross 2 grid. Each subplot is assigned a unique position 1, 2, 3, 4 in the grid. Everyone have a different position. Then plotting in each window. We have to plot them differently, so for different plots are created in each plot using the plot command. Titles for each plot are set using the title command. We have given different commands. Title commands, first is in top left, top right, bottom left, bottom right. All the plots will be appear in these position, and we will have different titles like plot 1, plot 2, plot 3, or plot number 4. So when we will run this code, we will have the following graphs. As you can see, plot 1, plot 2, plot 3, plot 4 are designed or are their plot in different positions. Now when you will call the win4 function, it will create a figure with four plotting windows arrangement in a 2 grid. You can customize the content of each subplot based on your specific data and plotting requirements. And from this task, our lab has been ended.